Well, hello, friends. Welcome back to Commute Talk again. Um, Thought I would talk a little bit about things I once believed about performance that were just stupid, or that were maybe misguided or premature or whatever. So, I, like so many other young C++ programmers, or really any language programmers, fell into all the usual traps of hearing someone with a bit more experience programming talking about, like, oh, this and that has bad performance, and you shouldn't do this and that because it will affect performance in XYZ way. And this is super duper common. So many people, they have all these ideas about what's bad for performance and what's good for performance, and I thought I would maybe talk a little bit about some things that I used to believe was bad for performance, and things that I did not I didn't arrive to these conclusions on my own. I just inherited them from other people, and I didn't have the experience at the time to be able to filter and think critically about what I was taking in. I was just like taking everything in. And I'm sure that many people do this, if not everyone. So, anyways, so one thing that I believed for a long time was that cache locality is like this great big performance improvement, and as long as you can achieve cache locality, then your performance will somehow improve. And I've spent like considerable amounts of time trying to improve the cache locality or data locality of various programs and things I've been working on, and very seldom with any tangible, measurable results. But because I believed in this meme so strongly, I would always just pat myself on the back anyway whenever I was able to, pack some data together better or whatever. I would just pat myself on the back and be like, oh yeah, dude, we improved data locality. That's awesome for performance. But measurement never really agreed with my internal belief that I had just improved performance. I was never able to prove that it actually did. And that's not to say that the cache locality or data locality can't improve performance in many situations. It's just that that I believed that I could make anything faster by just improving the data locality. And that, of course, was just not the case. Something else I used to believe was that virtual function calls in C++ are a performance problem. And I've spent a lot of time doing writing code or doing work that was just about devirtualizing, manually devirtualizing certain classes, and partly because I wanted to get rid of the vtable pointer, and also because I had this belief, not the belief that I concluded myself, but I got from other people, that the branches, the indirect branches of a virtual dispatch would somehow be a lot more costly than the more predictable branch of hey, are you this type? If so, take this branch. And again, devirtualization, I was never able to measure any real performance impact of devirtualization other than the memory impact of removing vtable pointers. Certainly on 64-bit architectures, that would shrink your class by 8 bytes, which can add up to a lot if we're talking about like a high volume object. But other than that, devirtualization never really got me anything. And then of course there's inlining. Inlining, I think everyone has a phase at some point where they think that inlining is the solution to every performance problem. I certainly did too. And there are still, to this day, many things in the WebKit project that are very hardcore inlined because of me. that probably don't really need to be, unless you want to maintain your, your very high pressed Dromeo micro benchmark scores on some subtest where inlining was beneficial. Inlining is really mostly making your code bigger, and there are cases where it makes something faster, but in my experience, inlining is almost always a micro benchmark optimization rather than a macro benchmark optimization. But again, that's not to say that there isn't a time and a place for inlining. Like on Serenity recently, I wrote some code that does optimized inline versions of image scaling for integer scale factors like 2x, 3x, 4x, and so on. And that code is certainly a lot faster because of inlining. But that's like a very conscious decision to inline there, conscious effort, compared to just something that I've done many times, which is to just slap inline on something and then see some micro benchmark go up and be like, ha ha ha, good job, pat myself on the back. And that's not great. It's not a great use of time. And then, of course, there is file size optimization or code size optimization. It's another rabbit hole I went down for a while. I remember I had this weird PHP script that I wrote that would compute the size of each function in WebKit and then sort them by size, and then I would start at the top and then like try to figure out ways to make those functions smaller in code size. And it was a fun exercise, but it certainly didn't give any real measurable results. I mean, like, the patches that I did were like, oh, reduce this function here by 4 kilobytes or 8 kilobytes maybe, sometimes even 16 kilobytes. But then at the same time, like, someone would go in some other part of the code base and add like a 256 kilobyte lookup table or something. So it was all like, it was all a wash. Or it was really hard to even stop the library or the WebKit framework from growing because people were adding so much at the same time that I was trying to shrink things, which was a little bit depressing. Anyways, I didn't get any measurable performance improvement from trying to shrink the code size either. It was just something I was obsessing about for a while. This is a depressing list. So let me tell you what has worked for me, what works every single time, and it is measuring and profiling the thing that you want to improve. And I know that it sounds obvious and boring, but it really is the solution to performance engineering, and to not be a cargo culting jackass like I've been. What you want to do is you want to figure out what is it that you want to make faster, and then you make a little program that can exercise only that thing, and then you just run that program in a profiler and figure out what are the hotspots, like where are we spending most of the time, and then you just figure out a way to do the same thing in less time, and you repeat that over and over and over again, and that's the most productive form of performance engineering that I've ever done, and I still do it that way to this day. And I recommend all of you do that instead of speculatively micro-optimizing things and worrying about like, oh, is this going to be fast? Will the compiler inline this? And then like, oh, can I do this or that? Just measure your thing and and optimize the thing that's actually taking up time. Anyways, I ran out of road here, so I guess I'm just gonna go into work and start the day. So thanks for hanging out with me on the commute, and I'll see you next time.